Hello everyone, welcome to the video. My name is Jov and this is Test-Driven Development Screencast. In this video, we are going to be focusing on showing an indication of an ongoing operation. So basically when the user tries to, let's say, sign up, in a real-world scenario, we are going to be making some call to a backend and that thing takes some time. So we are better off if we show some sort of loading spinner or some sort of UI that will tell to the user that something is going on. So we don't have yet any concept in the app for that situation, and this is a good start. This video is gonna be a start for that concept. So let's go back to the code. As we can see here, I already have written that we wanna consider the loading states, and particularly also we want to switch between the UI and the background thread in the view model, so that whatever goes in the that ongoing operation, like making calls and that kind of things, they should go in the background and we shouldn't be blocking the UI, so the UI will present some sort of loading. So actually we can start with the loading states, and let's see how that's gonna go. So first of all, let's enter the presentation mode, and here we are gonna start with writing a new test. And so what we wanna do here is we want to make sure that the view model is delivering, it is exposing a state that will represent that something is going on, like some ongoing operation. So we want to to make sure that the view model does that job, and then in the UI we can also write maybe a UI test that makes sure that something is really present on the screen. But first of all, we have to make sure that we are sending that event from the view model, that something gets, like, something is going on. So here I would write a test that actually makes sure that the states are being sent, are being delivered. So something like rendering sign up, sign up states test, something like that. And let's go ahead and write a test. So the test would be something like UI states are delivered in particular order. So I want to make sure that the UI, the controller, like whoever is the rendering mechanism, is receiving first a state that will represent some sort of loading, let's say the loading spinner, and then when we have sort of the results from the backend, we are gonna show that other state as well. So I'm thinking of something like, let's say, I'll represent them in a list. So for example, there should be two states, let's say the loading and then the actual signed up, and the order should be like something like let's say sign up state loading, and then sign up state signed up, and then here I need a user, let's say Tom. So that's gonna be the delivered states. So these two should be equal. So cert equals the list of is same as the delivered states. Now let's go ahead and make this. Well, this should happen when I have a view model create account, and then I pass here Tom, email, some password, let's say something like that, and Tom about, something like this. So the view model is gonna be my sign up view model. Now I have to also construct this one. So it takes regex credentials validator and user repository. And the user repository is gonna be the user repository, and I'll pass in memory user catalog, something like that. Now let's also define Tom. Tom's gonna be user with, I don't know, Tom ID, then Tom at friends.com about Tom. And then this is my act, and this is the assertion. So then let's see what are the delivered states. So the delivered states, first of all, is gonna be, let's say, a mutable list of sign up state. And then how do we fill this? I would say the view model, the sign up state, observe forever. And then when I receive an event here in the observer, I'll just add that into the list. So I'm just gonna add it, and then so that's my setup. Of course, I can actually pull some of this outside, for example here, but let's do that later. So then when I try to create an account, I have to receive first the loading and then the event that I expect. Now let's create the loading. I have to open the sign up state. Let's split and define it like an object. For some reason, the studio itself is not letting me do that. So that's my complete test. Now, let's first select the micro tests and run to watch this test fail. We want to make sure that it fails for the right reason. So as we can see here, it says that the common problem with the looper. So what we want to do is, let's close this. We need to extend with our instant task executor extension. Now make sure that it fails for the right reason. So as we can see here, we are expecting first the sign up state loading, then we are expecting the signed up, but what we got is only the signed up here. So let's make this work first. I'll open the view model. Actually, let's open it from here. And what we have to do here is let's move this into another function, and I'm gonna name this proceed with sign up. So basically, first goes the validation, the calls to the validator, and then if everything's fine, proceed with sign up. And here, what I would do is first say, let's make it a bit smaller maybe. So first we are gonna say the first value is gonna be sign up state loading, and then the result from the sign up. Let's see if this works. Yeah, it does. So now let's first check this all things in, and I'll say can deliver loading state let's say maybe the sign up view model can deliver a loading state to observers. Let's also rename this. I mean this underscore here that I've added to the mutable sign up state. I think it doesn't make sense now, because it makes sense when the if I had this private field here called also sign up state, so the underscore will make it different. But since I already have different names, I don't really need that underscore there. So that's something that I like. So basically what we can do here afterwards, let's check that rename actually first. Improved naming. Here now, for example, we can start working on coroutines and basically make this code, the user repository sign up. We can make that into a background thread, but at this point we don't have an evidence that we actually need to do that. So we are gonna work a little bit later on that. First, let's go ahead and do a little cleanup here in the test. So here in the test, first of all, we can pull this. Well, in fact, I can pull the 3 of these up here, and I can make them private. So then I have the delivered states, and then I'm setting up the observer. So I'm just gonna observe to like all the time, forever, to whoever, like whenever I receive in this observer, whenever I receive anything as a state, I'm just gonna put that into the list. So I'm then acting, I'm just trying to create an account, and then I make sure that the list of first loading, and then so this is the index 1, sorry, the index 0, then this is the index 1, they match the delivered states. So that's basically pretty straightforward. One thing that I want to do, let's first check this in. Improved the test by removing not very relevant details. So basically I removed these details are not that relevant for these tests. I just by moving them out, I feel like the test reads a bit better. So I don't care about the setup of the view model or the actual user. The user is not very relevant, and in that sense, I think here all this data that we are passing to the user, what we can do, we can create a builder, because like now the user takes only 3 arguments, which is sort of okay, you know, it's fine. But imagine if we have some sort of data structure, like a data class that has like multiple fields, and none of them is really, or maybe one is relevant for a test. Then I think, you know, constructing all that is gonna be too much of a mess having in a test. So what I prefer, what I want to do is I want to create a builder for the user, for example, that can hide all these irrelevant details for me. So basically I can say private val tom equals a user.build, and then I'm gonna have a user, because all these details don't really matter in this, for example, this particular test. And I think that's a good investment, because later on I will need more users, and then creating users gonna be way easier than just, you know, passing all these arguments there. So I'll be able to create users with like default data, or like just put whatever is only relevant for that particular test. So I think we can maybe do that. Or I'm thinking that maybe better not do that at this moment, because I don't want to waste too much time on that refactoring. Anyway, yeah, I think let's maybe proceed with what was planned for the episode first, and then I might do this as part of some other episode. So what I was thinking, just like extract builder for creating user, and then here I would have been able to say a user dot build, let's say a user dot build, something like this. I will be able to say, and then it will generate a user for me with like some, I don't know, predefined data. And if I need to, for example, change some of the data, I would say a user dot with email, and then pass whatever I want dot build, and that kind of things. Okay, I think we can leave that for a bit later or another episode, because this one might take too long. Okay, I'm clean now, I think. Yeah, what I wanted to focus next is offloading the sign up into a background thread, basically. So right now, I think we don't really need to do that, but if we want to, first of all, what we could do is we can use the ViewModel scope launch, and then this one is still the main thread. So if I want to offload this into a background thread, so let's undo first. I think the micro tests first I'm gonna run. Yeah. So this one, if I want to offload it, one way to do it is I can use the with context, and then here put, let's say, dispatchers IO. So I'm just gonna wrap that into that call. But the problem is that this must be within a coroutine, or this function has to be suspending. So what I can do, I can use the ViewModel scope to launch a coroutine, and this launch is in the same thread that this function was called, basically, which means it is main. So in the main thread, we are gonna set the first state as to loading, and then we are gonna in order to set the second state, we are gonna offload that into a background thread, basically. So first of all, let's run the tests, and let's see if this is gonna break anything. And of course it does. So the problem is that if we scroll down here, we are gonna see that actually there is a problem with the main thread. So it says that the main dispatcher doesn't really work, so we have to actually use the dispatchers.setMain from this library in order to replace the main thread for the tests. So what we should do is, here we need, for the testing, we need another artifact, and that one is, I have it here. Let me just copy. So it is JetBrains Kotlin X Kotlin coroutines test. So that's the one we need. I'm gonna sync. And I realized that this one also has an update. But that I think should be part of separate commit. So let's maybe update it so I won't forget, but I'll put it into a separate commit. Okay. Now, what we have to do here in the instant task executor, we have to reset we have to say the dispatchers set main and then I'm gonna use the unconfined for the testing. So the thing is that I need to use the same, whatever the instant task executor is gonna use, I need to use the same here in the actual view model in order to have the exact same thread where this is gonna be executed, so that the tests are gonna run, you know, the code and the test are not gonna be switching between different dispatchers and then end up not being in sync and then fail for some, like, make flaky tests. So I need the same dispatcher so that they're gonna, I'll make sure that the tests are running and the code are running sort of in a synchronous way, so then everything's gonna work as expected. So and because in the tests I'm not really I don't really need to test the asynchronicity, or like having all these different threading. I don't really need to test that. I most probably will be able to check that in the UI tests. In the unit tests, I need everything to be fast. So here I'm gonna add, I don't know whether this one or maybe, yeah, just experimental coroutines API. That's the one, and in the after all we have to do dispatchers, reset main, and the same thing here. So now, because we already used the instant task extension, if I run, let's see what's happening. Now these tests are failing because here I'm hard coding the IO, but as I said previously in the instant task executor extension, I have set the unconfined. So if I put here unconfined, what's gonna happen? This is gonna run, and that runs fine. So first, let's actually check this in. As I said, let's first maybe check this one in. Update. Up activity compose version, and then what we have here is introduce coroutine to offload work into a background thread. Good. Now the problem here is that in this production code, and we couldn't really use the dispatchers unconfined. So what we need to do is we need a mechanism that will allow us to replace. We need to be flexible to replace this exact thing. For example, for the tests to use unconfined, and for the production code to use the IO. So one way to do that is actually come up with some sort of interface, and then inject that inject different implementation in the sign-up view model based on like what's happening, whether it is a test code, whether it is a production code. So let's see. For example, we can have a class, say test dispatchers, and it's gonna have a val UI that's gonna be actually I don't need the UI. I'll just need the background, because for now I only need something to represent the background thread. So the background is gonna be dispatchers unconfined. Cool. So what can I do here is I can have a, say, private val dispatchers is test dispatchers, and this should not break anything because I just added something. Come on, my shortcut is not working for closing this because for some reason this indexing started to appear recently. So let's see. And now here what I can do is I can say dispatchers background, and that should still work, and it does. And now I can move this class first, like this class, this test dispatchers should be part of the tests only, but because now I don't have an interface for that one, I want to do step by step the things. So what can I do is I can first extract this one into like separate file in order to replace to be able to inject it, and then I can do the interface afterwards. So first let's see, maybe check this in first, one step at a time. Created a dispatchers class, created test dispatchers class, to define, to wrap background dispatcher. Coroutine dispatcher, yeah. Cool. Now I can, as I said, let's extract this one into let's say friends up. Yeah, it should be part of the tests only, but for now, because I will need to be able to inject it and work both in the production code and in the tests, I'll extract it in the main and then move it. And that should still work, and it does. And now I think I can extract this. I can inject this as a constructor argument. Come on. Okay. Yeah, for some reason it got blocked. So let's now see. First of all, I want this one to be dispatchers, and it should be private val. And then I can get rid of this one. Now if I run the tests, they don't compile because the imports are not working automatically for some reason. I think we saw that before as well. So all I have to just do is import, and then here import as well. And let's see if there is any, yeah, and this class as well. So I just imported them in the tests. Yeah, the tests are still working fine. So of course, let's check this in. So what happened is I'll have to check this application module a bit later. Maybe I should have made an intermediate commit with extracting and then do this refactoring, but okay. So yeah, now only the tests are basically changed. And and that's okay. So everything seems fine to me. So what I want to do is inject the dispatchers into the ViewModel. And next, what we can do is instead of test dispatcher, so now here, let's go ahead and extract an interface. Oops. And the interface is gonna be separate file that will be coroutine dispatchers. I'll leave it in the app package, and that's production code, but I'll need this field. So every implementation will have to define this field. And indeed here we have an override for that one, and it's the unconfined. And what can I do now is, if I go back here, instead of test dispatchers, I can inject the coroutine dispatchers, and that should still work. So now this ViewModel depends on abstraction instead of concrete implementation. So let's check this one in. So what happened is in the ViewModel I am injecting the interface. The test dispatchers got the implementation, and I have extracted this. So let's say extracted an interface for the coroutine dispatchers. And now what can I do is I can move this one. It can stay in the app as a package, but the source root should be in the tests. And now if I run the tests, of course, I was expecting the module to blow up, because the module, it does not see the tests. And now what I have to do, what I can do is I can do here a get, and here define a single that will describe the coroutine dispatchers. And here it's gonna have let's say app. I would rather do a default dispatchers. And of course this class does not exist. Extract a separate file. It's gonna stay in the app, but instead the studio starts to make me a bit sad, because let's extract a separate file. Instead of this, I need this one into the production. And of course it has to override the coroutine dispatcher, and it should be a dispatchers IO. So now the default dispatcher for background is gonna have an IO, and that's my in my application module, and everything should work fine. But for the tests, I can pass the test dispatchers and in the test dispatchers, the background is defined as unconfined, just as we have it in the instant task executor. So because both of them are the same, I have no problems in the micro tests. Cool. So now I'm still green, everything is fine. Let's check this in and see where we are. So what has happened here is the default dispatcher and the test dispatcher. So let's make them actually similar by, for the test dispatcher, I'll also add a space here. And the test is in the test package, this one is in the production. So introduced a production coroutine dispatcher. Yeah, coroutine dispatchers. That's it. Now let's go ahead and see where we are. So I would like to also make sure that the UI tests are working fine. So the emulator was not running. I think the first run is gonna fail because the emulator is still booting up. So I'll have to rerun, but it's fine. And what it means is that now we can work on actually we can also work on showing the UI in the UI some sort of loading. And as I said, this error appeared because the emulator was not running before. Let's rerun. And again the same. And now the tests are running. But for some reason it is not updating here the running state. Anyway, I think we are gonna see the results afterwards. I hope so. Okay. I don't see the results. So I had to rerun again. But I think they are passing because I would have seen an error down there where we see the launch succeeded here. It would have shown an error if a test was failing, but they all are, I guess, running fine, so everything should be fine. Yep. So now I think we are not done with what we started with the consider loading states, because yes, we are showing the loading states, but we are not, I mean, we are not done with switching. I mean, we are also switching between the UI and background in the ViewModel. Here we are switching, but the thing is that the sign up is actually calling to the catalog, and the user catalog is actually the endpoint where the things are being where we would actually have a call to backend. So this user catalog interface, now we have an in-memory user catalog, but when we have a remote user catalog, we'll have to make a call to backend. Now if we use retrofit, for example, it has internally things like, I don't know, switching threads and that kind of things. But the thing is that what if I want to make this part of the interface as a contract on my side. So if I don't use retrofit, or if I want to access database or like some other things like, I don't know, file system, whatever. I don't want to work on the main thread. So what I want to do, I want to sort of I want to be explicit that it is sort of time-consuming operation. So I want to make this this function suspending one, and then propagate back that that fact that this is a suspending function. Why do I want to do that right now? Because I think here when we would like to show we also want to show the loading of the that loading spinner. We want to show that in the UI, and we won't be able to test it as well if we have this flexibility to play with this interface. So let's first make this suspend. And now if I run the tests, actually it will tell me all the spots that I have to update. So first of all, let's fix this. And then we can make the one in the user repository as well suspending. And now I have to update the tests. So basically in the test we are calling a suspending function. So what can we do is we can do a run blocking. And I'll copy this, paste here. And of course, this one is also suspend. And this one is suspend. And this one also should be because there is no return from this test, I have to add this unit here. And let's run. Let's see what's left. Suspend. And that's pretty much it. So now all the tests are still running. Everything seems fine. But we also have now this flexibility to work with suspending. We have that suspending interface, and then if we go into the interface, and if we go to the view model, we don't really have to change anything because we already have this switch here. So let's check this in. So what has happened actually is we made the boundary call explicitly suspending. Yeah, I think that's gonna be pretty much okay explanation. So I think now we can, if I go back to my code in the to-do, we did consider the loading states, switching between the UI and the background threads in the view model. So all that is done, but what's left is show the loading in the UI, and basically that's gonna be sort of the wrap up for the sign up entirely. So that's gonna complete the sign up, and then we can continue on the timeline. So that should be a small thing to do, but basically we have to write the test for that. In fact, we can catch that into a UI test, so we can write a UI test for that. We can make sure that it looks it looks perfect. And then once we have that completed, we can continue on a timeline. But I think we are already running 45 minutes, so I think I'm gonna wrap this episode up at this moment, and then in the next episode we're gonna work on the loading in the UI and complete that one. So it's gonna be something I think interesting to work on. So thank you so much for the time and attention. I think we are done for this one. I'm gonna catch you in the next episode. Cheers.